Hello and welcome everyone, I'm Chris and today I want to show you how you can transfer programs from KUKA.Sim to a real robot. So in this use case we have the Ready to Educate cell and we're going to write a little program, an offline program in KUKA.Sim and then transfer it to the real robot, the KR4 here. Then change some points or the program a little bit on the real robot with our touchpad and then transfer it back to KUKA.Sim to have the actual or the most updated version of this program in our simulation tool. Let's get started with the offline programming. So once we're in KUKA.Sim, we first have to load our little simulation. In this case, it's the Ready to Educate cell. If you want to transfer your program to a real robot, you will have to load your own layout. In this case, I'm just going to go to our KUKA folder and then here to the special equipment, and we have the Ready to Educate cell here. And I will make sure to also use the KR4 that we are currently using behind me. So I will load this, and with a double click, it will generate in the origin of the simulation. Okay, here we go. And now you can see that there's a lot of applications and little objects that we currently don't need. So I'm just going to go to the cell graph and deselect some of the things that we don't need. For example, we won't need the curve or the vision or the vacuum gripper or the deposit, and also the angle. We won't need it. But we will need a specific exercise, so we will need not the palletizing paper, but the path paper that we're going to get our little pen here or the marker from the tool store, draw a little thing here on the paper and then bring it back. So this is actually the next task. We're going to go to the Program tab, select a robot, and there is already a main program. We're just going to create a new one. So if I go to add program, I'm just going to call it main draw, and with that, if I select it and make it active, we have the two home positions, and in between I'm just going to add first call for the pen from the tool store. So Ready to Educate marker from the tool store, this is the first one that I need, and then I will bring it back. So I will call another function, and here I will make again the Ready to Educate marker to the tool store to bring it back. And in between, I'm going to write my little offline program. For example, I'm just going to add a program and call it draw on paper. And now call it in between the pen statements here. So I'm just going to call it draw on. And if I run the program now, robot will go to the pen, get it, and bring it back because we don't have any program in between. You saw that pen is actually falling down a little bit here from the deposit. This is because physics is activated. I can actually change the physics entity now to kinematic again, so it won't happen. Before we start programming, let's just add a little halt here in the middle, so that actually the program stops in between, and then I can start my offline program. I'm going to grab my pen again, and here we go. And now if I go to the jog, I need to select the right tool and the base data. So in this case, I already know that I'm going to use my tool data 15. Actually, we got it from the controller, so we're pretty sure that it's the right place. And there's a little change here. The tool is not perfectly aligned between the gripper jaws, so I can actually change it a little bit so it looks better. But I'm pretty sure that actually my jog and tool data 15 is the right choice, as it would be on the real robot. In addition to that, I need the base data 32, which is, if you look properly on it, on my paper here, this is the one that I have to use in KUKA.Sim and then be able to transfer it to the robot. So as this is predefined, I will just now use it to jog the tool around, and I can now snap it with the orientation plus X, because this is my approach angle, on the first point that I want to go to. So I'm just scroll closer to my paper, select here this position, and with my TCP, and now I can start with the offline program. And here on my paper, I'm just going to add a little 0.1 for the preposition and then another linear movement. And if we jump back to the world view, we can now actually reselect the point number 1. I will set it about 50 centimeters above the table to have this preposition, so plus 50. And now that we have this preposition, I can start with the programming. So first point, then we have a linear movement to this one. I'm going to snap it again and go to the second point somewhere here and add this lin movement. And here we now have a circular motion. So again, I'm just going to snap my pen, go here, second point, so the end point of my circular motion, and add a circ movement. And as you know, we need an auxiliary point. So again, I can go here to 4 and snap it onto this auxiliary point and then say touch up auxiliary point. Or you could have moved the point number 4 directly with the move manipulation mode. Other than that, we still need a linear movement after our little here circ movement. So again, to the next point, lin movement. So this is just a dummy program, to be honest, to showcase this offline programming. And here we're going to add another linear motion, but in this specific case, we're going to add blendings. And now we still have to go back to our first point. Then I'm just going to add a lin movement here and drag it all the way to the end, and then create another PTP movement. And I can again make it 50 centimeters higher, so it's the same as my point 1. Okay, great. Now let's have a look what happens if I just run the program. Okay. The robot does exactly what it should do and does this motion, and now I just press play again and it will bring back pen and let it fall down to the floor. But this is not too important. What is more important to us right now is actually to adapt a little bit the speeds, because if the robot goes over this whole motion at that speed, it will probably break the marker. So I'm just going to select all my points and reduce the speed to about 0.1 second, and also reduce the speed of this PTP movement maybe 50%. Let's see again what happens, and now I'm just going to delete this halt in the middle, and let's see what happens. Go grab the pen, go to this position, make our movement, which looks good, and go back into the home position and bring back the pen. The program is ready and we could deploy it to the real robot. Let me add one more thing. Here we still have some programs that come from this little folder here that are modified for simulation interaction. In this case, we had to comment out some gripper tech topics. For example, if we have a look in this marker to tool store program, you will find some gripper set and gripper tech topics. These were commented out, and instead we use different signals. So at the moment, if we now program as it would be on a real controller, then KUKA.Sim won't understand the gripper tech topics here, and thus we have to use the ones with _s in this case, with the outputs that we normally use. This is why we have to go back actually in our little program right now and write the same names of our little here statements or programs as they would be named in the real controller. And in this case, it's not the tool store _s, it's the tool store here with an RE at the end. And we have to rename also this one to tool store without the S at the end. And if we transfer it now, the controller will understand those program calls and then automatically pick the right ones from beyond the controller. If you don't do this, you will get an error message. But actually this is only of relevance if you're using exactly the Ready to Educate cell at the moment. And if you do have your own programs and they are identical on the controller and in KUKA.Sim, you won't have this problem. Now that we've done the offline programming, we can start by connecting KUKA.Sim with our robot. So for this, we have two options. The first one is if your robot is connected to the internet, you can find it over the IP address, or in this case, we're going to use the Ethernet cable. So I'm going to plug it into my computer and into the robot. First that, and second into the robot. Now that we have connected our computer to the controller, we need to tell KUKA.Sim to find this controller. So in this case, we go to the KRL executor in the component properties of the robot and select in the motion execution mode the controller. And once we've done that, we can go to the three little points and look for the right controller. In this case, we directly see it. Sometimes it takes a time, especially if you want to connect online to an online robot which is connected to the internet. You might also find a list, so you have to select the right one. In this case, we only have one, and you can see on the lower left side that is connected and successfully connected now. And now we can press OK, and on the touchpad we can see that my user has started a debug session, and the next job that we have to do on the touchpad is actually to switch to the expert user. So I'm just going to write in the password, and now I can start a debug session, and there are several options to do so. The easiest is actually to press directly on play in KUKA.Sim. Now KUKA.Sim is comparing the files that are on the controller with the KUKA.Sim files, and you can directly see that he has found a lot of different programs and wants to overwrite them. In this case, we don't want to do this, so we can deselect everything with this upper little button here and select only the two programs that we did in offline programming before. Be aware that KUKA.Sim sometimes also wants to overwrite the config.dat. So make sure to deselect the config.dat if you don't want to overwrite all your tool and base properties. Now that we have done that, we can click OK in KUKA.Sim, and on the SmartPad, he will ask us to allow a remote access. And we just press OK here. And now KUKA.Sim is transferring the data to the controller. And you saw that the robot jumped because now we are in display mode and KUKA.Sim recognizes the position of the robot. So if I revoke here the system and now just go to the jog mode and move, for example, the axis 1 in the real world, it will do exactly the same in my simulation. But we want now to play our little program. So it was automatically selected already on my controller. So if I press play right now, you will see that the robot moves exactly in the same way as in the simulation. Now I can start the program and it will go grab my pen. Go back to the home position and now draw our little drawing in the real world. And bring back now the pen. Now you just saw that the program is not perfectly on the lines as on the paper. This is just because the paper in the KUKA.Sim simulation world is not as positioned as in the real world. That's why we can now start to actually correct the program on the real controller so that it fits perfectly to the real world. Let's get started with that. So I'm going to grab again my pen. and go to the first points, and now actually correct the points. The first one looks good, the second one too, but the next ones are not perfect. So I'm going to go a little bit higher in my world. So I'm first going to touch up the auxiliary point of my circ movement. And now I'm going to touch up the end point of the circular movement. And the last thing is to touch up the point number 6. And now I can actually restart the program and see if this works out as expected. And I'm just going to open the gripper for that, place it back. After this PCO, we're going to run the program. So let's have a look what happens. First, we're going to grab our little pen and now go again into the home position. And now go to the paper and let's see what the robot draws. It does exactly the program that we did while correcting points before. Goes back into the home position and now brings the pen back as expected. Let's transfer it back to KUKA.Sim. So in theory, you should still be connected to the robot controller here. If this is not the case and somehow you got back into the RCS module, there's a second way on how to connect. If you don't want to go through this default component properties, you can go here on this little gear on top of this program editor, and it will directly jump to this simulation configuration and to the motion execution mode. Here you can select again the controller. We're going to do this real quick. We will choose our current controller and it will connect us. So on the lower left side you see it's successfully connected now. And this will enable you again to do two things. Either you go here to the connection tab and there are 3 options. The one that you download a program from the controller, this is the one that we want to use right now. You can upload directly the program that you have selected, or you can, if you're working with Office Lite, transfer the whole configuration onto the controller. We are not going to do this right now because this would actually overwrite everything that we have on the KRC4 controller. So on the real robot right now, we don't want to do this. We actually just want to load an active program. And these are the same symbols that we can use right now. So load the active program from the controller, and I will just click on that. And there again, KUKA.Sim will ask me what do I want to do. Do I want to overwrite this main draw with the new points? So the main draw .dat and src files. I will just select them here with this multi-select button and click on OK. And then you can see that actually the program was updated. And you can see on the one side that this tool store program is now active. And this is not the one from the simulation. So we have to adapt that one. But in addition to that, if I go to one of the points here and go onto jog, the robot will jump to the new positions. But now be careful, if I press play, it will again synchronize with our controller. So I have to decouple from the real robot. Again, I will go to this little gear up here and go back to my RCS module. So the KUKA.Sim only system right now. And now I can play the updated program. Now let's have a look at what does look like in KUKA.Sim. I have to adapt the programs first because KUKA.Sim doesn't know those 2 programs. So I have to add this little _s. Same for this topic. I have to add for _s to actually synchronize again these messages with the gripper tech. And you can see here that it actually draws a different line than the blue line, but it's not very clear. So let me adapt this real quick. If we set back the simulation and I'll just set an output, this is maybe a valuable information to you too. If I set the output 31, it will enable me a trace in cream. I don't want cream, I want to have it orange or red like in the real world, like maybe this light orange. And I will do the same thing with my set output false, again the 31, and here type false. And with that it will draw a trace to when this program is called. So right now we have this orange line, and this is kind of my trace, and you can see that it's actually exactly the same thing as I would expect. So we have this little second line now, not again on the blue line that we have in KUKA.Sim. So what we can do is now we can go to modeling or select the paper path, and we could either now change its position so that it fits perfectly the real world, but you will see that this gap is not due to the wrong positioning, but more to a wrong size of this paper in this KUKA.Sim world. So actually the scale is just a little bit wrong, and we can now go back and go to the modeling here and actually add here for this paper, add a little transform with the modeling add-on and put our paper inside of it, and now scale a little bit, just a little, this point down. And this works with an S in Y of 0, I don't know, maybe 95, so 95% of the scale, and also in X, so an S X of 0.95. And with that it will reduce the size. And if we now go here back, you will see that it actually changed a little bit the position, but now we can reorientate the whole thing as such that it fits more or less to our problem or to the reality. Here we go. So this looks better now. And with these little adaptation, you can now change maybe your bases from KUKA.Sim to reality, or some other, how would you say, things that you imported into the simulation and that you want now to change. And you can see it fits pretty well. It's maybe not perfect, we can still tune it a little bit, but it's good enough. And with that, I would conclude the video. I hope that you learned a lot how to use the controller and the RCS module, and how to work with KUKA.Sim with the reality in connecting cables and stuff. And I hope that you will use it in your own production.
Thank you for watching this video. If you would like to see more interesting videos about KUKA Simulation World, feel free to hit the like button and subscribe to the channel. Looking forward to seeing you in the next video.
Industrial intelligence.